linear inequations. We've talked about linear equations in the form of y equals mx plus c. I'm now telling you there is another way they can be in this form here, ax plus by equals c, and this is the one we'll mostly be looking at in this particular exercise here. Only difference between linear inequations and linear equations is this in, and it's these symbols here. Okay, so less than or equal to, greater than and equal to. So instead of having an equal sign in there, you'll have one of these symbols. Now graphing them is quite simple. It's exactly the same as you would graph a normal linear equation. So let's start with the y equals mx plus c1. Okay, so y equals, what do we have, 2x. Let's do plus 4. You start, so if you're sketching that, you start at 4. For every 1 you run, you rise 2, you go to 6, 1, there's your straight line. Okay, from there is one extra step. Okay, so let's say it was y is greater than or equal to 2x plus 4. Our sketch starts the same way. We treat it as if we were drawing this for a start. Okay, so we start at 4, we look at our gradient, we run 1, we rise 2, that's 6, we end up here, and there's our line. Now, if this was not an equal to one, I would have to draw a dotted line. So if this was just a greater than, a dotted line. But because it's a greater than or equal to, I can draw a solid line. There's only one extra step. That's my boundary. From here, I need to work out which region is the region I'm looking for. So y must be greater than or equal to 2x plus 4. So what we do is we choose a test point. So I'm going to choose, what's this? This is about 4, 0. So I'm going to substitute 4 in. So y equals 2 times 4 plus 4. That should be a greater than or equal to, and that should be a 0, sorry. So 0 is greater than or equal to 2 times 4 plus 4. 0 is greater than or equal to 8 plus 4 is 12, is false. Okay, which means that I shade towards that point. Okay, if that was true, I would shade away. So false, shade towards. True means shade away. Okay, that's the convention. So we shade away from the region we want. So the region we were looking for here is above the line. Okay, now let's have a look at the other type of equation that we just looked at. So that's ax plus by equals c. So I'm just going to put some random numbers in. 2x plus 3y equals 6. Okay. And so how would we graph this? We need to know how to graph this before we can deal with inequalities anyway. So what I do is I let x equal 0 and I let y equal 0 as two separate things. So in this one, if x is 0, 3y equals 6, y equals 2. If we let y equal 0 as a separate thing, we get 2x equals 6, so y equals, x equals 3. And then I can sketch that graph. So x is 3, y is 2, and there's my line. Now, if that equation, 2x plus 3y must be less than or equal to 6, okay, so now it's an inequality, we go through the same process. We treat it like we treat this, and we sketch it the same way we did, so 2 and 3, and because it's an equal to, I can draw a solid line. And now we choose a test point. So I'm going to choose, let's choose 3, 2, so right here as our test point. Okay, so we substitute that in. 2 times 3 plus 3 times 2, it has to be less than or equal to 6. So 2 3s are 6, plus another 6. Is that less than or equal to 6? So 12 is less than or equal to 6 is false. I can't spell false. So we shade towards that point. So I shade above the line here. So underneath is my feasible region.